Alright, our next video for similarity, we will be exploring perimeter, area, and volume of similar figures. So the target is use the relationship between the ratios of perimeter, area, and volume to find perimeter, area, and volume of similar figures. One vocab word, similar solids, so go ahead and pause the video right now. Scan the QR code on your notes or go ahead and just Google similar solids and go ahead and write that definition. So again, pause and we'll pick up in just a minute. Alright, now we got that definition taken care of. Let's go ahead and this will be explore what happens when I have two polygons that are similar and what happens with their area. So first and foremost, if two polygons are similar and the lengths of the corresponding sides, the ratio are A to B. So if I have these two polygons, polygon 1, side length is A, and polygon 2, that side length is B, the ratio of their areas is going to be A squared to B squared. So all I'm going to do is just take that original ratio and square it. Remember that the ratio of the perimeters is still going to be A to B. It's going to be the exact same as the side lengths. And again, the ratio of the areas will be A squared to B squared. All right, in this first example here, we have two triangles that are similar to each other. We're not going to find volume. Obviously, you can't find the volume of a two-dimensional shape. So we'll start off by just finding the ratio, the scale factor, the perimeter, and the area of all these. So we want to go ahead and figure out what all these ratios are going to be. So first of all, make sure we pay attention to this. We're going to go shaded to unshaded. So I only have one side length for my shaded triangle and one side length for my unshaded triangle. And I have DF, which if you look at my similarity statement, D and F are the first and third letters. That corresponds with AC for my unshaded triangle, which also happens to be the side that we're given. Now we're going shaded to unshaded. So it's going to be 9 to 6, which is going to reduce to 3 to 2. So the scale factor is going to be 3 to 2. Now for the perimeter ratio, remember it's going to stay exactly the same. It's going to be the same as the scale factor between the two triangles. So perimeter ratio will also be 3 to 2. And then for area, we're going to go ahead and square this. So remember for area it's A squared to B squared. So plugging in our numbers, we have 3 to 2. So we'll square 3 and we'll square 2. And that'll give me 9 to 4 as my ratio for the area. Now in example 2 here, we want to identify which one of these two solids is similar to the given prism, which is the one in the middle. And we're going to check this just like we would check any other figure. And what we're going to do is we're just going to compare side lengths. And how do we know what to compare with what? And again, just like other figures we've done, we're going to go small with small, medium with medium, big with big. So if I look at my original, we've got 3 is my smallest side here. Well, that's going to have to compare with 6 on this first prism here. So 3 to 6, that scale factor is going to reduce to be 1 to 2. In my given prism, after 3, the next biggest side is going to be 5. And 5 will correspond with 10, which is the next biggest side over here. So 5 to 10, again, will reduce to 1 to 2. And then my biggest side on my given prism will be 7, compared with 14. 7 to 14 will reduce to 1 to 2. So since all three of these are the same, we can go ahead and say that these two prisms are going to be similar. All right, let's go ahead and check the second prism. So again, we'll go small to small. So that'll be 3 and 9. 3 to 9 is going to be 1 to 3. After 3, I've got 5, which will compare to 15. 5 to 15 will be 1 to 3. And then lastly, we'll do 7, which is compared to 14, which is going to be 1 to 2. So obviously the first two are the same, but the last one is not. So these ones are going to be not similar. So again, very similar to verifying that polygons are similar. We can use the same checks for similar solids. All right, so similar solids theorem again. If I have two solids where the scale factor is a to b, the first three we've already talked about, and that's the so a to b is the scale factor. The perimeter ratio will be exactly the same as the scale factor, a to b. The ratio of corresponding areas will be a squared to b squared, and then the ratio of corresponding volumes will be a cubed to b cubed. Now, how we're going to go ahead and use this, we want to figure out, so we were given two cylinders A and B, and they're similar with a scale factor of 2 to 5, so that's given to me. We want to find the surface area and volume of cylinder B, given that the surface area of cylinder A is 96 pi, and the volume of cylinder A is 128 pi. So first things first, let's go ahead and find all of the different ratios for this. The scale factor is given to us as 2 to 5, which means the ratio perimeter is also going to be 2 to 5. To find the area ratio, we're going to square the 2 and square the 5, so we get 4 to 25. And then for the volumes, we're going to cube. Now again, remember, we go back to the scale factor. So to get from here to here, I square it. And to get from here to here, I'm going to cube it. So we cube the scale factor. 2 cubed is going to be 8, and 5 cubed is going to be 125. Now, in order to use these ratios, first let's go ahead and find the surface area of cylinder B. Now, we're given the surface area of cylinder A is 96 pi. So again, let's go ahead and write a ratio of the two things that we are comparing. We're comparing cylinder A to cylinder B. Now, since we're dealing with area, we're going to have to use this area ratio here. So we're going to set up a proportion. So 4 over 25 is going to equal, and again, it's going to be cylinder A to cylinder B. Well, we already know that 96 pi is the surface area of cylinder A. We don't know the surface area of cylinder B, so we're going to go ahead and we'll call that X. Well, let's call it A for area, or S for surface area. So to solve this, we're going to cross multiply 4 times S and 25 times 96 pi. 4 times S is going to be 4S, and that's going to be equal to 96 pi times 25. Remember, just treat the pi like an X, so it's just 25 times 96, which is 2,400 pi. And to solve for S, we'll divide both sides by 4. And S will be equal to 600 pi. And again, this is going to be in feet squared. So the surface area of cylinder B is going to be 600 pi feet squared. We can use the same method to find the volume of cylinder B. Again, we are given that cylinder A's volume is 128 pi. We're still going to use cylinder A over cylinder B, but this time we're going to use the ratio of volumes. So 8 over 125 is the ratio of volumes, is going to equal the volume of cylinder A, which is 128 pi, over V, which we'll call the volume of cylinder B. And again, we're going to cross multiply to solve. 8 times V is 8V. 125 times 128 pi will be 16,000 pi. Last but not least, divide both sides by 8. And V is going to equal 2,000 pi. And again, this is going to be in feet cubed. So this is how we use the ratios. If I want to find a perimeter, I'm going to use the perimeter ratio. If I'm going to use the area of one, to use the area ratio. And if I'm going to find volumes, make sure we're using the volume ratio. Okay. As always, if you have questions, write them down the side so you can ask them next time I see you. No you try nows for today. And that's it. Have a good day.